My name is Carl Dobman, and I'm the Dean of the College of Architecture and Design at Lawrence Technological University. A little bit of housekeeping first. We're live streaming tonight, and so if anyone is joining us online and you have questions, please ask your questions through the YouTube comments. We'll be monitoring that, and we can ask your question during the Q&A. Also, we're offering AIA continuing education credits, and you can sign up in the back of the room, on the table in the back. The productive relationship between theory and practice is something that we constantly preach as a defining characteristic of Lawrence Technological University. Professor Henneberry has worked very hard this year to curate a lecture and exhibition schedule that champions this productive relationship and build opportunities to discuss design more broadly in cross-disciplinary contexts. Deidre couldn't be here tonight, but I did want to thank her for her patience and her tireless work in putting together the lecture series. So it's my pleasure to introduce James Timberlake this evening. James is no stranger to this part of the world. He grew up in Western Michigan, and he attended UD Mercy for his undergraduate education. He then went to graduate school at Penn. James was awarded the Rome Prize and spent the year in Rome from 1982 to 1983. And James is also a really incredible model for theory and practice, which is why it's so exciting to have him here. And he's a role model in a couple of ways. The first way is that he both teaches and practices. He teaches graduate level design and research studios at the University of Pennsylvania School of Design. He's held visiting professorships at the University of Washington, Yale University, and the University of Michigan, where I met him, I think we figured out in 2004, as well as the University of Texas at Austin. He lectures internationally to academic, industry audiences, and to the broader public. Recent talks in Singapore, London, Melbourne, New Delhi, and Mumbai. He's been in practice with Stephen Kieran since 1984 as Kieran Timberlake. Their office has about 120 professionals, and they do work all over the world. They take on projects that include programming, planning, design of new structures, as well as the conservation, renovation, and transformation of existing buildings, with special expertise in education, government, arts, culture, civic, and residential projects. A small side note, and we spent the afternoon walking around the studios and talking about studio culture. A small side note is that, and you'll see, I think, a video of their office, all of their furniture in their office is on wheels. And this talks to a broader studio culture that both builds on projects, as projects progress, as they start up, as they conclude, the teams also evolve. And so what you'll see in the office is that those mobile desks allow for a movement and a vitality in the office where adjacency matters. Teams are reconstituted depending on project needs. The second point of note related to the productive relationship between theory and practice is that the firm is committed not only to delivering the highest quality services to their clients, but also to pursuing ideas that push the practice of architecture forward. Since 2002, they've co-authored 5 books on architecture. After more than 10 years, their 2004 book, Refabricating Architecture, continues to be of critical importance in our field. Funded by the inaugural Latrobe Prize by the AIA College of Fellows in 2001, the book explores the practice and making of architecture as a manifesto with a central question that what could architecture be if it were manufactured like cars, ships, or planes? This question then pressurizes the manner in which we operate professionally. Professional relationships, contracts, fees, all of these things might be reconsidered and break us out of this simple mold of fee for service. If we're able to do that, that changes the relationship to research and development. So in this case, research initiates the inquiry, but research is also the potential outcome of this. The firm is recognized as a leading firm in design research. They're award-winning, productive, and actively engaged in both. They've received over 160 design citations and awards, including Firm of the Year from the AIA in 2008, and the Cooper Hewitt National Design Award for Architecture from the Smithsonian Institution in 2010. In 2012, James was appointed by the Obama administration to serve on the board of National Institute of Building Sciences. More recent projects include the US Embassy in London, which is what you see an image of now, integrated campus plans for Rice, and even last night, I was telling him that my graduate design studio was looking at the dormitories that they designed for Cornell as a case study. It's my pleasure to have James visiting us and sharing his recent work. Please help me give James Timberlake a warm welcome to LTU.
I'm just going to pull this out in case I have to rest my hip. It's really, really good to be back in Detroit. I always enjoy coming here. It's good to see people that I know, and I'm grateful that the dean from UDM, Will Wittig, came. A good friend of mine, Roman Holansky, and many others are here. And also in the audience, I just wanted to point out that one of our Indian partners in a venture that we're working on, Amber Malhotra, is also here because his wife is working with Henry Ford Hospital. So it's good to be here, and I always enjoy coming to Detroit because I think it's a vital, energetic, and rapidly growing place, both for technology but also industry coming forward. And I think you're very lucky to be part of that, and I always like coming back to be able to talk about it. I have a couple of housekeeping things that I have to do first. This is not my slide, but you just need to know that this is sanctioned AIA talk, and I'm not going to read it out loud to you, but you can obviously earn credit for it, and that there are some learning objectives that we were supposed to put in front of you. And again, I'm not going to read them, but you'll learn a little bit about Karen Timberlake and about research and about what we design and how we can integrate those practices together in a cross-disciplinary way. Since you are working on the campus and building here, I told and mentioned to Carl that I would just bring some student life images that we've done just to begin to introduce the lecture a little bit. But what I want to do is talk over the course of the lecture a little bit about our research on what we've been doing, both as professors of architecture, teaching and taking our students abroad. I want to show you just a snippet of the India housing project, the Ideal Choice Homes that we're working on, and then take you through several projects, including the new London Embassy that is under construction that opens this year, and a couple of, and I'll end on one project that we didn't win in a competition with David Chipperfield, against David Chipperfield, but a house that we've completed in New York. So I gave Carl a bit of warning that I had way more slides. I usually edit pretty well. But if you have to leave, just know that some of the greatest images that you're going to miss are at the end of the show. So if you walk out, I'm not embarrassed, but I hope to be done by 7 o'clock. So let me just begin with some of our student life projects. You know, we always do our work with queries. You know, we always put a question out there, and I think it's something that both Steve and I and many of the people from our office, you know, brought from our academic experiences, both in undergraduate and graduate school, and as we've incorporated research into our practice. For instance, this dining hall, this collective of 2 residence halls and a dining hall at Middlebury College was really formed around a question of how can a new aesthetic reinforce campus architectural traditions and frame views of the campus and the grandeur of the mountains. And I'd have to take you in depth into this particular project, but this dining hall is, set up on a podium, engaged in a hillside with the residence halls behind it, but sits almost like a tree house into the trees, looking at the mountains beyond. And some of the things that come out of doing a project like this, these gabion walls here, these wire cages filled with rock, are part of the excavation of nesting this building into the hillside. We took that rock and then created a sound wall that is now ivy grown and merged back into the landscape, essentially, adjacent to the building. How can we conceive a residential complex that builds community while serving as a model for environmentally responsible student housing? This project at UCSD in San Diego, part of the University of California system, incorporates both natural ventilation and high building performance to make LEED Platinum housing on that particular campus. And these hallways along the outside edge are outside. You can't do that in Michigan very well, but in California you can, and you can see the Pacific Ocean from some of those prospects. And then when you get into the rooms, the rooms are loft light, they're adaptable, and then they have abundant natural light and are knitted both to the campus but also to the landscape. At Cornell, I think one of the questions was, how can architecture unite academic and residential life? And Carl knows this project, but there are a series of sort of finger-like buildings that travel down the hillside that allow the landscape to move through the buildings. And these social spaces were treated like landscape. They have views both into them from the landscape and out to the landscape, and the landscape was brought over the top of them with green roofs, so they were incorporated back really into that landscape. And this is a view out of one of those dining halls, but there are social spaces, a seminar room, a library, and lounges that incorporate pieces of that and rips of light that come through those particular spaces. But the more hermetic, if you will, student housing, forms 2 kind of hands or gloves around those interstitial spaces. And that really, allows Cornell and that university campus to knit uniquely back to Ithaca down the hillside. We've worked on several Eero Saarinen projects, both in London and at New Haven. This is Morson Stiles, one of his last projects. In fact, I think this particular project was completed after his death in 1960. At Yale University, how can we re-envision the landscape architecture and program conceived by an iconic architect to create a place of inspiration and welcome? These were thought of by Saarinen as kind of clusters of Italian hillside housing. These towers of stone, these slot windows, and the Yale students hated them. And now they're one of the most beloved places on campus because we redid the landscape outside of them, we renovated them on the inside, and we found spaces like this in the Undercroft that created light wells and knitted new social spaces on the campus, buried in the depths of the building, that allow you to move seamlessly inside and outside of the building. And this is a climate that's not unlike Michigan. In New Haven, it gets abundant amounts of snow and has 4 seasons. And this is something, I would think that LTU would want to think about, is not just plopping, dorm rooms like, a Holiday Inn might be set on the side of the highway, but, really try to figure out a way to engage that housing deeply into the landscape. Some of the art spaces that we've done, how can we forge a new relationship between city and campus in the design of an innovative arts complex? At Yale University, a LEED Platinum series of studios, that, allow for adaptability. In this particular case, we often say that this is the very first building that was ever renovated by us, and it was done within 1 year of being on this campus. The reason for that was this was a swing building for the art and architecture renovation program to be renovated. They renovated that building, then took the architects back out of this space and carved this up into sculpture studios. And this created a whole new campus on a block adjacent to the art and architecture building that created a whole series of interstitial walkways. We've worked on urban campuses as well. In this particular case in Charlotte, how do commercial and social spaces integrate into an academic setting, blurring the city within the campus? I mean, UDM is building, you guys are building here at LTU. It's not just the boundaries of the site that we need to deal with, but we need to think deeply about how we can integrate these buildings into the city fabric and into the campus landscape and not be isolating our students and our students and our academic programs from the city. For 40 years here, we've tried to inoculate ourselves by walling and fencing things because of localized incidents and crime, but that's changing and that's transforming, and we don't want to have a 40-year next legacy of buildings that are then isolated from the outside. And so this building, an urban building, which is quite tall, it's 13 stories, quite a mark on the campus, also has 6 academic programs in this high-rise dispersed throughout the building, including architecture. And the folks come from the Charlotte campus downtown, engage in it, and go back out to the campus. So these queries become really important texts, by which we begin a narrative about the things that we design. And I would think that these are the kinds of things that students, you might want to take back to your work as well. But in the context of that, one of the things that we have done as teachers and as professors is take our students out of the laboratory and out of the design studio into the places that they need to design. And the most profound of these has been to take our students at the University of Pennsylvania each year over the last 8 out of the last 10 years to Dhaka, Bangladesh, a place in the world that is intensely occupied, very dense. I'll talk a little bit about the population in a moment, but we've chronicled that work in our book, Alluvium. And in that book, we use some gerunds to talk about the kinds of things that we saw and we'd like to talk about, and how we looked at it and analyzed it, and then what we did with that information as researchers and social interrogators of Dhaka and Bangladesh. We did a lot of deep research that we've shared within this book and analyzed that, and then a lot of mapping as well, and then took those images and that research and began to design for solving some of the housing and water problems that Bangladesh is notorious for. This is a country that is the size of the state of Iowa, and Iowa has somewhere between 3 and 5 million occupants in it. And it has, Bangladesh has 165 million people in the size of the state of Iowa. And the other critical fact is that half the time of the year, half of Bangladesh is underwater, either from the north, from the alluvial flow coming down from the mountains and the snow melt, or from tidal flow from cyclones being pushed up the Bay of Bengal, and flooding the lower half of the country. And so there's constant turmoil of where one lives and how one lives, intense poverty, and a country that, like India, like some of the other sub-Asian continent countries, were agrarian societies that are becoming urbanized. And so you go 3 hours outside of Dhaka and you see these kinds of rice fields, and you wouldn't think that there would be 165 million people, in a country like this, because there are acres and acres of people and you only see 5 or 6 people in the middle of the rice paddies. But here are the floodplains of Bangladesh. The alluvial flow from the north, the cyclonic activity coming up from the south, putting 150 to 165 million people at risk all the time. It's a country knit by rivers, and rivers that are actively moving because of the alluvial flow. The rivers have actually transformed and shifted and migrated over time. So here's some of our research just chronicling the Brahmaputra River migration from 1760 over a period of time, moving 125 kilometers just in a very, very short period of time, and moving back and forth. They braid, so in winter of 1999 versus pre-monsoon of 2004, you can see that these widely shift in terms of their activity and where they're located within that common river valley. What they create with that alluvial flow is moving, tons and tons of sand and silt. So here's this is actually a picture of the Brahmaputra that is also fed by a bit of the Ganges and other rivers as well. What you're seeing in the distance, and we crossed over to that, is what's called a char. And that char is in about its 5th or 6th year. So all of that silt and that sand didn't exist there, 5 years prior to this photograph. And it's slowly been built up over time. And the average length of a char is about somewhere between 9 and 17 years. Eventually, that river is going to move through there again and move all of that off. But in the meantime, it becomes a place of life with houses and farms on it, and it becomes a place of farming as well. The activity of all of that movement of water and land causes great migration, as well as the desire to improve life and obviously well-being. And so there's a great rural to urban migration. Unlike the United States, which has been tipping back and forth over the last 50 years, we're back into an urban migration in the United States. But in some of these sub-Asian countries like India, like Bangladesh, there's a terrific groundswell out of the farms, out of agrarian land into places like Dhaka. And Dhaka is one of the fastest growing cities in the world. It's not unlike Lagos, Nigeria. It will be over 20 million people in Dhaka itself by the year 2020. And Dhaka, in terms of its environs, its boundaries, is about the size of the city of Philadelphia, which only has about 2.25 million in its SMSA and about 5 million people in its surrounding counties in Central City. This is what that looks like. This is crossing one of the main rivers. Those are ferries beyond. These are there are a few bridges that cross this river, and this is how you get from one side to the other. Meanwhile, you're moving across water that is about the color of the seats in this auditorium. It's intensely polluted. It's full of toxins, tannic acids, a variety of other things, because the water, the free-flowing water, is also the means of not only fishing and food production and transportation. So you imagine there are oils and gasoline and other effluents in this water. But it's also where sewage is flowed, into these things. So you get tetanus shots before you go to Bangladesh, and you get you learn not to paddle with your hands as you're going across the river. Transportation is a huge issue. The intermodal confluence of bikes, pedestrians, intense traffic in 19th century, 18th century, and 17th century city lanes is just intensified every day. We think we have an infrastructure problem in the United States. This is infrastructure in Dhaka, Bangladesh. And so wires are just put up, they're never taken down, they're coiled up, they're ready for the next, tap. Illegal tap. Water is illegally tapped because fresh water is hard to come by. And so some of the challenges to urban growth include not only the rural to urban migration and the increasing amounts of people in slum areas that are pocketed throughout the city, but trying to get goods and services to them because they're part of the informal economy that goes on in these countries. They're the bicycle, taxi drivers and so forth. But this is the kind of places that they live. Informal housing, built at the fringes, built of scraps, bamboo structure, CI sheet, found objects, and so forth, enough to keep the water out, enough to provide for shelter from most of the elements, but at great deal of risk from flooding and from disease and from other things. Bangladesh, like India, like some of the other sub-Asian continent countries, have a lot of brick-producing facilities. India's gotten some of these under control. Some of the other more developed nations, like India, have as well. But a lot of these kinds of things come to these sub-economies because, for instance, back after World War II, Japan became the garment industry. That moved to China. Then it got shoved down to Vietnam, and then over to Myanmar and Thailand and Malaysia. And now the garment industry is in Bangladesh. Likewise, brick producing is a cheap way of building, getting building materials, but it's highly toxic to polluting the air and creating conditions for global warming and other issues as well. Over 15,000 people a year alone in Dhaka, about 1% of the population dies each year just from the pollutants out of these brick factories. But this is how it's transported, loaded into a boat, scuttled down the river, then hand delivered off. Meanwhile, they attempt to create more land. There's a lot of land hoarding and gathering. And so this map is in analyzing how much land has been raised and filled since 1975. And so what they do is pump sand out of the river. There are pipes running all over the groundscape out of the river, raising the land, dig, elevate, dwell. So they're trying to raise the land relative to the water table over the clay cap. But what happens is that the floods move that refilled land. It makes it more alluvial, if you will, and creates more flooding issues and more problems. So here's a sand scow moving that sand, from the river where they dredged it downstream. Here's some of that sand that's been moved and now being pushed around in order to make one of the new highways reaching out toward the northeast out of Dhaka. So how does Dhaka grow in the future? We imagine that it's going to continue from 1600. It was that blip at the upper left in 2007 or 2012 down in the middle here. That's all the reaches of Dhaka at that particular time, but we're imagining that this land filling is going to continue to fill in the lower lands of around the southwestern portions of Dhaka, and it's going to create continuing issues. So we've studied the water problems and how those might be remedied as architects. We've taken properties in Dhaka and looked at how they might be utilized over the course of the dry season, the wet season, how flooding might inform making the use of the land more purposeful, how that might be utilized during different times of the season when they have to have events on this particular property. And how those synergies of land use might come together for local neighborhood consumption. These are the kinds of things that we've done with our architecture students and then used them to go to the local politicians and government and share these ideas with them. This Dhaka Block was an idea of taking the Jersey barrier, something that was made out of concrete, but now is made out of plastic and hydroformed, and usually filled with water to create those temporary barriers around construction sites. To reimagine that block as something that could be molded into a way of storing potable water, gathering rain, storing that water, filtrating it, but having it become a building block to create low-income or middle-income housing in Dhaka. And this is something, with temporary sheet and other kinds of things could become a shelter, but form throughout the seasons, wet and dry seasons, a continuous form of water that isn't full of arsenic and some of the other things that they're getting from the groundwater. Khan understood Dhaka, and I just share this with you because Luke Khan was somebody that, when I went off after being at UDM, went off to the University of Pennsylvania. He died the day I got accepted there. People, I think this guy probably said he knew you were coming. But this was a famous architect that really understood landscape, environment, building within that, and creating something iconic that really was about the nature of those people in Dhaka. And I thought I'd never get to see this iconic building. I'm sharing it with a little bit of it with you today because I thought I'd never get to see it in all the times I've been living. And now I've seen it 6 times. I've been through this building 6 times. In the Parliament Hall, this is the umbrella ceiling looking up at that hall. And it's just kind of reflective of something really elegant, really beautiful and simple and monumental, but emblematic of the Bangladeshi people. So that research that we've done, at Penn, with our students, it's research that we do all the time at Timberlake. We have this wonderful place I'm going to show you in just a minute, but we're constantly trying to understand the holistic elements of architecture. It's not just form, it's not just aesthetics, it's not just site or environment, but it incorporates all of these things that you can read up here. Ego, concept, logistics, money, light. One of the things that going through architecture school, as it was conveyed to us very early on, it was only about a couple of things. And if you could solve those couple of things, you were doing pretty well. Well, getting out into practice and teaching, what we found is that it really is hundreds of things, and they all needed to be solved. And they all need to be solved holistically and not out of balance. Otherwise, you end up with messes of buildings that don't work, that people can't support, that cost a lot of money, and probably aren't very beautiful either, even though you were trying to solve for that. How do we do that? Well, we work collaboratively. We work interdisciplinarily. We bought a building that's an old bottling plant in Philadelphia that had closed in 1988. It had a variety of other uses in it. This is sort of the arc of the day on the second floor. This is where the bottles were brought up and washed and then filled and then taken back downstairs to the cooler room or back out to the loading dock. Everybody is on wheels in this particular space. There are no partners' offices. We're all out in the open. Even the conference room walls can be moved. Incredibly mutable, agile, and nimble. And so over the course of when projects finished, people can just unplug their desk, take their phone, their computer, and their gear, and kind of re-plug into another team where they've been reassigned. And what you're seeing is the light of the day move through that space, through the central skylight, and across the floor. We raised the floor, created 2 active air highways in that particular space, and put the data and the power underneath the floor. On the lower level, you're looking into our shop, which we put out in the front street because we make things as architects. And we want people to understand that the craft of what we do is still something that's of worth, and it's not something to be hidden. I mean, this is a making neighborhood, or it used to be a making neighborhood with 3 breweries, shipbuilding, and other kind of craftsmen in this particular neighborhood. It's now full of millennials and others and a lot of housing. But having a making space on the lower level, right out on the street, we thought was a gift back to the neighborhood, and it could be opened up. We arrived via that lower level via a stair that was offsite produced by We Design by Zahner out of Kansas City and shipped in. And here is the bottling plant, and here's the new plant over there on the right. This space was designed to be naturally ventilated, because it was lots of steam, lots of water, lots of energy being expended by the machines. When you clean that out of there and you go to a lighter, less intensive use in some ways, a different intensity of use, there's a different kind of energy that's going on. But we wanted to retain the natural ventilation of this particular space, which we do. The windows open, the skylights open, there are exhaust fans on either end. We put air highways under the floor, and we went through a year and a half worth of experimentation with our staff with 400 sensors that we placed in that space, taking data from that space and surveying them about their use of the space and where they were comfortable, what they were wearing, what time of day it was. What we found was that there was a peak, a kind of threshold beyond about 82 degrees and about 60 to 70% humidity in certain times of the summer or on the shoulder seasons, where that just started wilting people around 2 o'clock in the afternoon. So this is data that we have that we're going to publish and share with the profession very, very soon. But what we found is we needed to shave that peak off. And so this last summer we added about 30 tons of cooling to help the desiccant system just shave off that top edge. So now we're able to keep that space more even. We don't have the sine curves of cool to warm like this any longer, but we now have a sine curve that's more like this. It's more temperate so that people understand what they're coming into on a daily basis. And they know it's never going to get above about 78 to 80 degrees, but that humidity is also going to be dropped into probably the 40s to the 50s where it's more temperate so that they can be more comfortable throughout the day. Our research spaces are throughout. This is a diagram of how that was analyzed and how all of that works and the abundant natural light that we can get into that particular space. We deployed a wireless sensor network that we invented, which is now branded Pointillist, that we're trying to commercialize, that we can place out of the wall, in the middle of the wall, on the inside of the space, in a variety of areas with microsensors that have then the ability to go back to an app that we've developed that can show up on my iPhone or somebody else's iPhone. This is the iteration of all of those sensors. And then take that data and give us a variety of data from, dryness of air, humidity, temperature, latent outdoor temperature. So we have a variety of cycles that we've been able to map that inform the building management system and allow us to run this building efficiently. We also modeled some of the employment of some of the work that of the choices of materials in this particular space. And we do this with all our buildings through a software that we've designed and we've invented that is a plug-in to Autodesk Revit called Tally. So we're software engineers. We invent products. We research materials. We are deeply invested in understanding the life cycles of buildings and how they inform our choices of what we do. And then we investigate the materialities of that, of some of those efforts. These are mock-ups that you see on our lower level in Ortlieb's. The upper level is the big room above, of mock-ups that we've done for buildings that we've designed. The wood wall system at the University of Washington, mock-ups of concrete that we poured in the shop. We can weld, we can form different things. We have a 5-axis milling machine, so that screen that you see for UCSB that would ultimately be cast out of GFRC or GFRP is milled out of foam as an initial prototype to show the client so that we can fail early and fail fast. Because that's really been one of the issues for architects and designers, even in the auto industry, is that, when you don't, we're all building prototypes. The very first building we build is a prototype. Well, how do you get out of building your very first building as a prototype? Or the second building is also a prototype, or the third building. You have to fail early and fail fast, and the only way to do that is to start mocking this stuff up and getting it out of drawing information sooner. And so by mocking up these materials and casting those things, we're able to do that and understand them. The India project is informed by this arc of information that we're doing, but Amber came to me about 5 years ago and said, there's roughly a 27 million unit housing deficit in India and not fast closing. And I've read your book, Refabricating Architecture, and do you think it might be possible to do off-site constructed housing more rapidly at a higher quality for low income, middle income, and higher income groups in India that is sustainable and environmentally responsible? And we said we'd like to try to take it on. And we became a kind of joint venture partner, and we brought in some other partners with that. But together with his design for manufacture, and are working with them on the programming. This early phase of this project was understanding the climate zones in 10 different climate zones, 10 Tier 2 and Tier 3 cities, the resource consumption of buildings of this sort, the logistics of building them and getting them there and making them, and the cost modeling for everything from a very, very small 32 meter square sort of single-story studio all the way up to a 90 meters squared, about 900 square foot single-story house. And we've since then taken, as you saw in the earlier images, this to a G+1, a ground +1, or ground +2, or ground +3 models, and we're looking at them even further than that, and developed a series of system elements that create enough mass so that they are both self-shading and self-ventilating with infill pieces that create a variety of different kinds of mass customizable, mass-produced models that we're pursuing in a variety of around India, and studied their environmental impact and their, how they perform throughout the day, and then how logistically they might be assembled. And so in order to fail early and fail fast, we invited Amber and some of his partners back to Philadelphia very early on, and in our early shop mocked up some of the elements out of cardboard first at scale to show them the scale of what we were doing. See, I'm never too far away from Detroit. I even collect old used car signs as well. And then we began to test out, concrete sampling and dimpling for the exterior walls of this. What you're looking at here are different means of three-dimensionally forming the outside wall of the columns of the building, which form the mass of the overall house. And then modeling through a variety of softwares. I think this is Ecotech in this particular case, but a variety of other softwares we've employed as well, which demonstrates that a flat panel is the most absorbent of not only some of the insulation factors, but some of the direct energy from sun passing around throughout the day. But as we begin to shape the face of that flat surface, we begin to deflect some of that energy immediately throughout the day. So we're taking some of that incident solar and reducing the impact on that element right from the get-go. And so we've created both pocketed windows, and you'll see this in a moment, and then dimpled walls that allow us to modulate that energy that then ultimately might be brought through the house in a time lag over time from outside the wall to inside a wall, because some of the nights in India can be very cool, particularly in the shoulder season. So we want that energy to get on the wall, some of it, but we don't want it all to get into the house. So we want some of it to be dissipated. So we tried different elements to form that concave shape and looked at it from an economic point of view. And then in Ahmedabad, we did our first prototype. What you're seeing there is the C-shaped columns with an infill panel that is dimpled, and then an infill wall and window set up. And this is not the house itself, just a piece of the house. But what we're trying to do is understand how the slabs and the columns can come together and create a moment connection, how difficult they were for men to lift them without a crane. In those early days, we were imagining that we wouldn't have a crane on site. But now we do have a crane on site, and we've expanded this prototype to a second effort. This is expanding the prototype appreciation and looking at improving. You can see on the lower story the old prototype to the right, the new prototype about halfway down to the left, and you can see how those C-shaped panels have been turned around. Because we have been learning from our design from manufacture with the local precaster and our other Indian partners as well. We continued looking at shaping materials, for other projects as well. And we've employed this, this strategy on a variety of other projects as well. For instance, this is a shading fin that went through 6 iterations that is now deployed on Brown University's new science building. A GFRC shaped fin. You can see the structural steel tube that reinforces it, that allows it to clip onto the facade. And I already spoke of the UCSB screen earlier as I walked you through that lower level. The struts for the embassy in that very first slide, the New London Embassy, one of these sits in our lobby here. That's about 11 feet high and about 11 feet side to side in that kind of bowsprit. And this is the lower half of that assembly, and you're going to see more of it in just a moment here, looking up the facade. And I'm going to talk a little bit about the embassy. So we work overseas. We're working in India. We've worked in Singapore. We've worked in Malaysia. We continue to look for opportunities globally, but this was a commitment that we won by competition in 2010, competing against Paycob Freed, Richard Meyer and Partners, and Morphosis over here. And they're all friends. We're all still good friends. But we were the winners at competition, an international jury comprised from American jurors and the UK. And I'll just take you through the embassy. This is a view that we did during the competition phase. Typical London day, post-rain, with a wet street and an active sky, a kind of reflective near dusk wall. This is the site between Vauxhall. This is down here next to the bridge is the MI6 headquarters that was blown up in the last Bond movie. And then Battersea Power Station, the power station where Pink Floyd did the rock, some of the rock concerts. That's now all being surrounded by housing. And this whole area is the last largest area to go under construction in London, urban area to go under construction in London. And it's all a catalyst because of the U.S. Embassy deciding to move from Mayfair and Grosvenor Square to this site. And this is, for you that think we have too much government, this is a real estate deal. There is no tax dollars going to this particular project, to that cube. It's all because back in 1960, the U.S. government invested in Mayfair. Mayfair is now some of the most expensive property in London and in the world. And they were able to sell that property, the old London Embassy, which you'll see in just a few minutes, and pay for our fees, pay for this building, pay for the kit out of the building, and pay for the site on this site. And so that's how this building is getting paid for. This is what this is going to look like in about 2025 with all these new high rises. About half of this is already finished or under construction. And there will be roughly about 25 to 35,000 new housing units in this post-industrial area near Covent Garden Market. This is looking up the Thames River toward the Houses of Parliament and the London Eye. The diagram of this was really, kind of 4 parallel lines of Pimlico, the Thames, the major high street, 9 Elms Lane, and the viaduct with this linear park, with our site, embedded within that. And how to tie, this was a diagram we showed at the competition, how to tie those strands together, how to knit this building into the urban fabric, but not have it stand alone, given all the security concerns and everything else, but to be open, welcoming, reflective of, the United States government and culture, and be welcoming, in that particular environment. So we studied a variety of shapes, and I'll come to that, back to that in a minute. But we wanted to knit this into the landscape. And so on that 4.5-acre site, we created a pond, which is part of a public park, which is accessible to people and not walled off from anybody. Hid, the security elements of the landscape and of the building to the building itself. Created a series of entrance pavilions around the outside, and then wound that landscape up through the building into 6 gardens that are carried up through the building and plugged in to different spaces. So it's essentially an office building with a couple of public lobbies, a major couple of meeting spaces, public meeting spaces on the lower level, and a series of stairs that allow you to walk through the building but get from each of these 6 gardens that are wended throughout the building and throughout the cube up through the building. So there's that linear park. There's all that housing that's going on. There's the embassy. That bridge going over to Pimlico is proposed, and they've bonded for that, and eventually in the next couple of years that will be built, so there will be a direct pedestrian linkage from Victoria and Pimlico over to this particular site. The site itself, as I noted before, is surrounded by new buildings, which we couldn't anticipate the design of at the time, mixed use, housing, commercial, and then a series of what are called CACs, or entrance pavilions, the main one to the upper right, the consular pavilion to the lower middle, and the service pavilion to the lower left, which allow you access through screening to the site. Major consular walk up through a garden into the consular lobby, and then a building that's oriented north, south, east, west with a very compact cube shape that is the most efficient form for environmental impact, both on the city but also on the energy consumption of the building. So this is kind of a drone view, if you will, of the pond and the walk and the outside event gardens, a view in landscape. And you'll see some of this under construction just at the major formal lobby on the east side. The main event gallery, 3-story space, connected by a bridge and a stair, facing out to the garden, a view down in that particular space. The consular, 2-story consular event space, not event space, but visa space, where people come for U.S. visas and come for U.S. consular business as well. So there's a series of booths and a waiting space. This too overlooking London and the park. And so you can imagine you're spending all this money. I talked a little bit about holistically designing buildings. You're spending all this money and you want a building that's a 50 to 100-year building at least before you have to renovate it, that is energy efficient, is really thoughtfully thought through relative to life cycle use and so forth. So we worked with our engineers, Arup, to think about holistically the total building energy that is being consumed here, and that ultimately we might be able to do without. So we're gathering some from the sun. We have some ground source watering. We have rainwater harvesting. We have daylighting, other energy production systems. We're getting some grid energy in. We're producing some of our own, but with the air changes per hour and the operational loads and the schedules and all of that, we have a sum of total building energy that we have. But one of the things that isn't shown in this diagram is the fact that this building ultimately can be a district energy exporter eventually within the next couple of years once they get the system of other buildings linked up to it over time. One of the ways that we're managing that energy is through that outer envelope. it's a very secure inner envelope, which allows us to get abundant natural daylight, and the layups, for that glass are classified, but something that Kieran Timberlake worked out with the Department of State. And then the outer envelope is ETFE, which is anticipated to have solar integrated solar panels behind it. A mock-up was created, and then we've gone through a series of fail early, fail fast on that, but I'm going to take you through the construction of this building. So this is the site just under construction, and the core coming out of the ground. This is about 2014 when the steel started going up. You're looking up London, and then the steel up and topped out, and the glass curtain wall going up. And then the ETFE and the outer struts starting to be put on the building. A detail of that. This was about 9 months ago. Most of that ETFE up, and you can see how the light now begins to transform, take these shading devices, transform the light both in and out of the building, and some of the views from Nine Elms Lane from out far with lights on, now starting to merge on in the building, and the lighting conditions on that outer layer that's shaped and formed through a year's worth of iteration of trying to discern the most efficient shape to maximize shading on the building, but also create an aperture for view out of the building that was syncopated with that particular element. Different views of that. You can see some of the other housing going up. So this is a aluminum and cast outer structure that's attached to the curtain wall that the ETFE then is stretched over the top of. And it's wrapped on three sides, the east, south, and west sides. The north side face out to London is kept open, and there's another view here. And then a view just up the river in context. And then a dust shot. And the kind of southeast view. So where are they moving from? They're moving from here. This is Saarinen's competition winner in 1958, 59, I believe it was, of the U.S. Embassy in Grosvenor Square. You can see this image. The eagle was added later. It is not moving. It was done by a sculptor and given to the building. So the building is now certified and has been sold and is being turned into a hotel. And we were approached by the developers, since we knew something about the building, to compete against Foster's and Chipperfield and one other firm in London to discern, what we could do both as a hotel and as apartment condominiums to convert this building while maintaining its best characteristics. And so we, do the usual analysis of the existing conditions. This is a kind of view of our scheme, which I'll come back to in just a minute. Went through a series of modeling studies of how to maintain the profile of this building and not interrupt the view sheds while maximizing the addition of some program, both for housing and hotel. And came up with a scheme that allowed us to basically put the hotel out to the public face, out to the garden, out to the street, and turn the private housing into the inside, all by arrival at two different lobbies, essentially three different lobbies, one on the north, one on the south, and one on the east. The hotel lobby on the east off the park, and then the condominium lobbies off of either end. This was a section through the building. We found parking in the lower level and a way to get to that parking and service. Turned the current consular hall into dining and event space off of a major lobby down at the lower level, and then created a landscape above all of that the condominiums look out onto. Taking Saarinen's careful facade, which was pretty cheap back in the day, and thinking that we have to reassemble that somehow, but get energy efficiency out of it due to the energy laws in the UK. Looking at this, we imagined a double skin facade, so an inner layer, acoustical layer, an outer layer that would allow us to modulate that energy coming in from the exposures on that particular side, and then Saarinen's facade through a careful analysis. And what we found is that we could get to a very, very high level performing building out of something that wasn't originally intended that way. There was roughly a 35% estimated current embassy penalty on that particular building because of the way the energy currently worked. And the new construction hotel baseline reduced that to this area over here, to that kind of zero construction. And we took it through a series of stair steps to see that we could make an improvement over typical hotel construction in London, which expect their buildings to be high performers in a very, very creative way. Here's a view, our rendering from the park, looking at that scheme with a new green roof and the condominiums and the extra story set back, but added around the top layer because that height was already there, but it was a mechanical space. But now we could make it into high-end apartments as well. The ground floor becomes, the public hotel lobby and event spaces, but maintaining those elements, and you'll see views of that in just a minute. This glass cube sort of set down in behind Saarinen's screen-like facade, that allows it to maintain its best characteristics, but opening the street up and removing all the security accoutrements, from each side of the building, thereby knitting it back into the landscape. Maintaining the lobby. If you've ever been in this lobby, you know that there's a pool that was intended by Saarinen that was then covered up after a diplomat fell over backwards during an event into it. So they paved it over, but it still exists there, and that obviously gets opened up for making a hotel lobby that's very much part of. These are all our renderings. Looking out onto the park from the restaurant, one of the hotel rooms, and then one of the condominiums looking on the back side of that, and then a view on this other side. Needless to say, we lost to the British. Chipperfield beat us, and if I had to lose to somebody, I'm okay losing to him. He's a pretty damn good architect. So. The very last project I want to show is a house that we completed in New York that has been widely awarded and widely published. Pound Ridge House, a Revolutionary War site. This is where lots of Revolutionary War and the British troops traipsed over this property. Over the course, and you'll see it in just a moment what it looks like on the ground. It looks like this. This is a third growth forest with rock outcroppings coming out of it. These rock outcroppings are monumental. The owner, businessman in New York, and his wife collect art, have two sons that are now out of the house, have a kind of music interest. But the site, all this red is all that rock outcropping. So, where do you place a house, in the context of those rock outcroppings? And I think what we chose to do was bring you through those rocks and up the hillside, but then nest the house in amongst the rocks. But how do you do that without it kind of demeaning the rocks? How do you have this dialogue, this simultaneous discord or accord between, something man-made and something that's, tens of millions of years old, fired. So we slipped the lower level of the house, the garage and service pieces of it, and an entrance at that lower level off of a kind of forecourt with a major stair coming up through the house. And then an upper level has a kind of a private suite of bedrooms and studies and a public series of rooms, a set askance from that, connected by a bridge that goes out through the landscape. The house sits perched up in amongst the rocks, and becomes its other outcropping. But this building was built through a series of sips that are clad in 4 different polishes of stainless steel, so you get that mirror-like imagery. This is a view up in the rocks along that edge, and those panels are set in and out in order to dissipate some of the energy. But to command 35-mile views, they're up on the top of the mountain here, the top of the hill. And then there's this play of phenomenal and literal transparency, the literal transparency being the windows. Obviously, you can see in and out of them. The phenomenal transparency per Slutsky and some of the Cornells back in the 1960s, the phenomenal transparency are the mirrored panels. So a mirror is phenomenal transparency. You're seeing through something, but it's fictive. And that's what the mirrored metal does here. And then it's modified by the different levels of polish that go around the house. So the stair, you enter that lower lobby of the building, and the stairs slowly build and bring you up to that initial level. And then there are cuts out through those sips, that look out with long views or look out to localized views that are very much, sculptural in and of themselves, and very much art without being man-made. There are long galleries in the house for their art, and abundant natural light that comes ripping through the house. The kitchen, dining, living area is all one big room that opens out onto the landscape. And the art is interspersed in amongst that. The bridge takes you across that landscape and above a path that wends its way between the rocks below into other areas of the outdoor area. But the house decomposes into the rock, through the mirroring as well. So you get these moments where you don't really know, you're kind of faced with real rock and then fictive rock as you walk around the house. View at the end, a view from down below. The photographs of, the house just above the rock and the kind of relationship of those panels to the rock outcropping. And then what happens during the season, how the photography, starts to tell a story of how this house transforms. And this is a critical element of weathering and of transformation in sight that is, I think, really important. That it's hard to get across to students in architecture school, but it's something that comes with a great deal of experience and making mistakes. And it's something to aspire to, trying to find this. And you begin to understand why young architects do some really interesting things, but aren't necessarily at their full level of craft until they've had, a number of these buildings underneath their belt or in their belt, to really understand, the dialogue that you can have with a site and a series of materials, light and weathering, that really transforms how you think about making something. So, then in a third season, the snow-cropped houses and the defoliated trees, exfoliated trees, with the sun returning, and then a last view of a detail that I want to share with you. I just have to say that, this comes with the same kinds of budgets that everybody looks at this stuff and says, oh, you've got $1 million budgets and all of that kind of stuff. We have budgets like every other architect. And we think of money and budgets and program just like it's part of a design act. And so, we work with very, very modest costs per square foot to make artful things. And it's through the choices and the engagement of an engaged client that you get those kinds of relationships. Yes, this house costs a little more than a normative house might on the fridges of Philadelphia. But, our office, and some of the other projects that you see, and the U.S. Embassy, have strict budgets that we haven't been able to go get more money for, whether you're operating on yourself or whether you're operating for the U.S. government, for a client. These are things that are all part of the Design Act and become, really, really important aspects of this. And I think that's oftentimes people look at this and say how beautiful this is. This house must have been, several $1,000s a square foot, and it wasn't. But it's just about careful thinking and careful design. So with that, I thank you all very much. I'll be glad to take some questions. I don't know if we could have the house lights up a little bit, but if there are some questions or two, yes.
During the Center in the City project,
Yes.
you said you intended on lowering the city and the campus to provide a reduced crime rate for the center? Or does lowering the city center project, the lowering within that project, occurred as a strategy after the crime rate percentage got reduced through other means?
You conflated 5 different comments into one. So I'm just, with all due respect, you heard 5 different slides and conflated that into one statement. What I said was that when we're doing things like housing in the city, projects in the city, like the Center City building, which is a high-rise building in Charlotte, North Carolina, or we're doing a project for LTU on this campus, or downtown at UDM in the city, where obviously there have been issues of, active moment of issues with the neighborhood. The tendency over the last 40 years has been, obviously, in any urban area, whether it's Philadelphia, whether it's Charlotte, whether it's Detroit or anybody else, to privatize the land, put up a fence, put up a wall, and keep people out, right? So I said that. What I've said is that when you're thinking about doing a campus in the city or in the suburbs, as we have at Charlotte or in New Haven or at, in Detroit or here, that one of the things that we have to think about is the legacy, not that came before the last 40 years, but what we're designing for and aspiring to become in the next 40 years coming on. And how can you secure students and campuses, but also design for allowing the campus to be engaged in the city and to be open. In the case of the Center City building, that particular building has no fences around it. It's engaged to a park. The Science Center is down a block. The Center City buildings are a block away as well. There are housing projects only a couple of blocks away. But because of the way we've engaged that interior and exterior property, it helps to both mark turf and set expectations of behavior, and also protect, and encourage the students to be both in and outside of the building. In the case of a campus like this, or certainly one downtown where the first reaction is to put a fence up. I think there are other ways to handle that through landscape and other kinds of things, as we've done at the U.S. Embassy, that allows to meet really, really strict, highly classified, secure regimens for that particular building, but do it without fences and without walls. And you can experience it when you go there, but what you'll see is that we've engaged that building and its confines deeply into the landscape, but it does feel as though we've set it so apart from Nine Elms Lane or some of the other landscape when they take the hoarding down, when they take the construction walls down, that it isn't going to feel like it's not seamlessly into the rest of the urban landscape. Yes. Let's do gender equity first. Here, we had a male. We're going to do a woman. Please.
Obviously, it would be easier to go ship a product that's already been manufactured and less time-consuming. So how do you build in funding for making the many prototypes for these projects?
Because first of all, you have to run a profitable business, correct? Otherwise you go out of business. Otherwise I wouldn't be here talking with you, right? So we have to make money, and we have to make some money. But some businesses are, and we were just talking about this because the firm just finished a strategic plan and rolled it out to, our 8th in 32 years, and we just rolled it back out to our staff and associate everybody else. And one of the things that I often show is a diagram of some other firms, and it's all about finances. It's a little bit about design, a little bit about staffing, a little about workplace and everything else, but it's all about the money. Steve and I, we're not independently wealthy, he can tell you. One of my best friends from UDM can tell you that. We didn't go into it. We designed a practice where we can make money, and we can make a living, and we can have a family, and we can do all that, and we can support everybody else. But one of the things we learned while we were doing the Latrobe Fellowship and refabricating architecture was that when we went to visit the car industry and the automobile and the aerospace industry and the shipbuilding industry, one of the things that we learned about with processes and everything else was that they were doing R&D, and they were taking a certain percentage of their profits, and rather than pocketing them and going home and buying that really expensive car or something else, they were turned back into the business to keep that business nimble, agile, and fluid and energetic. And so Steve and I began with about 3 to 5% of the profits, gross profits, being returned back into the firm. So some of the research salaries are supported that way. We do get grants. We're actively pursuing more grants. We've set up a nonprofit to allow us to get grants in, but we don't have that quite in place yet. As well. But that profit that is coming from our pockets and turned back in is helping to sustain some of the inquiry and the prototyping and the failing early and failing fast that we need. We still make a profit on those projects. Those hours are the same amount of hours that would have been charged to that client, but we're redirecting some of that time rather than drawing to the nth degree. An interesting short fact, Morrison Stiles project, right? Saarinen project. How many sheets of drawing, this is a little quiz. How many sheets of drawings in 1959 do you think Eero Saarinen made to design that building and design it for construction for a contractor? I'll take 3 answers. How many? 5 sheets. Well, you're a little low. Somebody else?
10.
You're still really low.
60?
Did you say 60?
Yes.
You got within 1. Very well done. 50. A week in New Haven. 59. Now, second part question. Let's see if you get this one right. How many sheets do you think Kieran Timberlake took to do the renovation of that building? Given codes, given liability, given risk, given all that. Yeah, yes, sir. 505. 505. And Steve Kieran and I had that calculus and said, every one of those sheets, back in the day when we got out of architecture school at UDM, the calculus for that sheet was, each sheet was 40 hours, 1 week. So if you had 12 weeks and you thought you were going to do 60 sheets, you could then figure out how many architects and draftspeople are you going to have to draw those sheets out, because it was 40 hours a week, right? Now with CAD, it's like, I've got a full building model on the embassy, I've got a full building model on Morrison Styles, and we're just grabbing details off of that thing because we built the whole model and we're just putting it out in an analog form, to a contractor. That's really dumb. That's really dumb because it wastes time, it wastes expenditures. Now you're increasing the amount of RFIs you're getting from a contractor because they want to understand, well, how does that little bit here with this little bit over here, and so forth. So one of the things that we've tried to do is reduce the amount of those by doing some of this prototyping, by saying, this is the way the detail wants to be made. We'll draw that. That sends the information about intent and about scope and about all of that kind of stuff. But it also allows us to get deeper and earlier in materiality of the buildings and how that might form, and analysis of that. Taking the energy modeling off of these things and incorporating that so our buildings are more highly performing, which is lowering ultimately the operating costs of the building. You were next. Yes, you. Yeah. Yeah.
I'm curious if you could talk about how your firm decided to take on or pass projects.
We have a criteria. We have a marketing coordinator. Several of the partners, myself, Stephen Kieran, evaluate it for its meeting our strategic plan. And so we have aspirations in our strategic plan in terms of kinds of projects, development of staff, initiatives in the office, all of that kind of stuff. Does this project meet that, meet those characteristics? There's a subtext to that obviously schedule factors in. We're seeing some projects right now where schedules are just unrealistically short, and we know if we propose on them, we're going to have to go to them and say, that's unrealistically short, and we're going to either waste and expend marketing time and effort that's useful to some clients if they've made up their mind about that calendar and we can't meet it. There's no point in us taking it on. And then budgets. And then there's the nuances of partnerships and other kinds of things. We partner with other firms, but if you're getting a $30 million project in a faraway place, partnering with another firm where you're going to divide fees in half, or 40 somehow, what that does is really water down the product that you're going to end up giving to the client, because they're not going to get as intensive, an activity on that, because this firm and this firm have to split that fee somehow. We've been very, very careful about trying to take on, and go after kinds of projects that have both advance discourse, advance, our goals and objectives, but also try to meet a range of variety of initiatives, like, taking on the housing in India, for instance. There's no fee for that. We've been doing that for 5 years. We have partnership equity in that with Amber and with another partner in Ahmedabad, but we haven't seen rupee one or dollar one from that yet, and it's purely speculative. We're doing that on the basis that if we could do 27,000 units, or 270,000 units, or 2.7 million units of the 27 million unit deficit, that goes a long way to helping to repair the world. And so we take on planning projects, for instance, and public-private initiatives and other kinds of things. We try to evaluate. We have a group in our office called Community Involvement, KTCI, the Community Involvement Group. We're roughly expending about 10% of our hours, somewhere between 5 to 10% of our hours annually, gross hours per year across the firm, on community involvement projects. So some of you just got an email from us talking about a project for Phil Abundance that we have on our website that we designed an app for, but you can look at what they do to try and redistribute food in Philadelphia, but understand how difficult it is to line up nutrition with low cost of food, from a reseller, if you will. And so we put that in our lobby. We designed an app for it. The app is accessible on an iPhone. You can play the game and then you can donate. This year we donated money last year to them. This based upon people in our office and visiting. This year we're moving that's going to our bank. They're going to donate, but we've told them that we would, as people play, we would match that to 100% of what people play going forward. So one of the things that we have to do as architects, and one of the things that was instilled in me coming to Detroit in 1970 and being at my alma mater, and then going to Penn and being in Philadelphia, and somewhat being the son of a minister's kid, is just that this isn't about running a business, and there's more to running a business and more about being an architect than making money. And some of it's education, publicly speaking, teaching, initiatives with people who can't afford your services, and so forth. Some of it is trying to do the right thing for your clients, no matter what budget they have. Some of it is trying to repair the urban fabric part of the community in. And taking on, trying to teach students, being a professor, teach students that legacy, going forward and handing that forward as well. And I think that's just, so we try to do that through our publications, our research that we publicly publish, the books that we've written, and the public lectures. Because, ultimately, in this world, we're on an island home. You can, those that don't believe that there's climate warming, or those that do believe there's climate warming, it really doesn't matter. What matters is we're on a finite piece of land. Our little selves in that, just looking inward for a minute, we can be the, biggest person on earth, so it seems. But in the end, we're contributing something to this island home that is a legacy. And it can be a negative legacy, it can be a positive legacy. I personally have kids. I hope it's a positive legacy. I hope they're going to have kids. I hope it's around for numerous more generations. And I think the only way to do that is through positively impact, both socially, professionally, academically, and in other ways, economically. And I just, I think the other thing I learned from going through architecture school, the thing that probably offended me the most, quite frankly, and I think it's changing, but it still exists, is just the arrogance of many architects. It's all about their ego. It's all about, they run over contractors because their building isn't, done the way they thought it was supposed to be done. treat people, indiscriminately and other things. That's given this professional legacy that I'm not proud of, and that Steve and I have tried to change. And I think it's just something that in the long term, you can have your cake and eat it too. You can make a profit, you can have a nice life, you can raise a family, you can do beautiful buildings, you teach, you can do all of it. You just have to figure out holistically how you prioritize and how you choose to build this world that is around you. I'm most disappointed, frankly, in my carbon footprint, because my carbon footprint is really damn big. Not only do I like cars, and I only have one, and it's okay, but I fly a lot. And we did a carbon footprint analysis of our firm many years ago, and who do you think had the biggest, darkest shoes? Kieran and me, because we were flying all over the place, which is, carbon fuels and everything else, and no matter how you do that. And so we try to cut that down by doing some of these lectures virtually and, do some other kinds of things, but it's hard, really hard. You need the face-to-face contact. You need people to feel your presence, and engage in this kind of way. So I think it's an important legacy. I and Steve and others in our firm hope to leave. But we're trying to kind of call out the arrogance as much as we possibly can as we go forward, because I think it's rampant, particularly as people, gain fame and gain money and other kinds of things. It's like, hey, who are you? How can you be who you are and true to yourself? And that's just something I just want to try to get. I'm not trying to preach. I'm just trying to get out to the students, because it's just something I remember in a lecture, years and years and years ago, maybe at UDM, maybe at UPenn, maybe someplace else, but it was something that just kind of stuck in my head that we have something that we're being trained to do that is really, really important to the world, and that we need to give back. And how do you holistically kind of pull all that together? And hopefully not do it at the expense of your kids and family and everything else. I try to make every one of my kids' baseball games. One last question. Yes?
For your offices and firm offices, was your priority when you were looking for a space that would have bigger space that the public had access to, or was that you found a space first and then you had to get the other?
It was the latter. It was the latter by stretch of the imagination. We looked at, like most cities, post-industrial cities, where manufacturing is fleeing, and micro, becoming micro manufacturing, steel making, car making, everything is, being automated, being made smaller, being dispersed, being diasporized, if you will. We couldn't find. We didn't want to be in a corporate office space. We didn't want to be in a 9-to-5 space in Center City, Philadelphia, with 11-foot ceiling. One of the other legacies of trying to look for a space beyond trying to find makerspace was that since the inception of the firm, one of the things that we've observed about our staff is, and that when we go to other architects' offices, is that most architects and other businesses, because of rents, are shrinking space. Schools are shrinking space. They don't want as much lab space, right? Because it costs money. So, if in the center of things, those are market forces, those are higher rates, those are higher rents. So we always kept looking at the fringes of Philadelphia, the edge conditions, a little further out, a little further from downtown, but on transit lines, easily accessible, that had enough space that allowed us to always increase the amount of space that we've given per person in our office. So we went from roughly about 60 square feet of space per person in our very first office, startup office, to now we have, I think, about, in this whole thing with 120 people, we're at around 500 feet per space. So if you imagine a desk is 6 by 6, you know, that's about 36 square feet. An aisle, that's about 50 square feet, right? Plus some increment of other social space or other growth space around the office. You might be up around 50, 75, maybe 100 square feet per person in total gross without a shop and without other kinds of things. We're about 5 times that, and we're about 5 times the volume as well. Why do we do that? Because we want people to be able to take things off paper space, get them out of the computer, put them out large, pin them up on the wall, understand the scale of these things, feel the scale of that, make things, draw them full scale, do those kinds of things, the whole gamut of things that we've learned over a century of how you make buildings. The makerspace, where it was positioned, was partly due to access, partly due to putting it on the street for not having office space on the first level, you know, with people walking by and being distracted and seeing all the office clutter, but having something active there. But it came out of obviously discovering this building, which was like the 40th building we looked at in over 5.5 years as we were looking for buildings. And they were all different spaces, some down at the Naval Yard, on the river, up in the northeast. We looked at 2 corporate spaces that wouldn't allow us to have a shop space, wouldn't allow us to bring the bikes into the building, right? You know, so you develop these criteria, you try and wait and have patience and look, you know, and this is what we came up with. It turned out to be, what was interesting about this particular building, I like long-winded answers, but I'll finish with this. It's a bottling plant. The brewery was across the street. The brewery had been around for over 125 years, over 3 breweries in the Northern Liberties neighborhood. After World War II, right after the World War II, the breweries all saw their beer consumption starting to amp up with soldiers, you know, and people coming home. And so they needed up the production. So this particular brewery said, look, we need to take the bottling out of the brewery, increase the brewery space, put the bottling in a different location. They found that across the street and put up this bottling plant. The beer got brewed across the street, piped across the street at the second level, came through the wall, and then got distributed into that space. And I think what's interesting about it is that a space like that, you know, there have been 1,000 wonderful adaptive reuse projects in this region and in the Detroit area since I left school here and left the city. And there have been award-winning projects and, you know, converted lofts and other manufacturing space and everything else. This was just one of those opportunities where all of a sudden there was serendipity between the amount of space we needed, how it was distributed, the amount of light coming in, the fact that we could naturally ventilate it. A developer who owned the brewery site and owned the site on 2nd Street on what is now our backside building, was trying to buy this building because he wanted to put a hotel on that 2nd Street site. But the neighborhood association had decided they really didn't want that hotel, at least at the scale that he was proposing it. And they didn't want service trucks coming into what is now our loading dock / shop space, which is what would have happened because it would have been in the back of the. So the owner of the site decided to sell to us, not at a huge premium over the developer who wanted the project, but he wanted the building to deteriorate further. He could get it cheaper. They were playing a game. It was locking up 6 sites around the neighborhood: the brewery site, 2 empty sites across the street, the site on 2nd Street, and this building. And once we bought that building, 4 of the 5 other sites all got sold 4 months. And now all of them have housing on them, or housing under construction. The brewery, which was a ruin and never could be adaptively reused, was torn down. Townhouses going up on that townhomes going up on that site. Infill projects. The neighborhood was thrilled by us coming in. We're a low intensity use, an office use, kind of quiet, certified a building, it's on the Federal Register now. A modern building on the Federal Register, and repaired the neighborhood. It's a kind of, really, we lucked out. I feel very lucky. Didn't I give all those to you? Oh yeah. Yeah, we got a tax break for the certification of the building, but we had to do certain things to the exterior of the building to maintain its integrity, retain certain characteristics exterior for that reason as well. So, look, thank you all very much. I've kept you from dinner and more school and everything else. Thank you.